Question 4 in our materials test. First, this part is draw the Lewis dot structure for calcium and chlorine atoms. So Lewis dot structure is my outer shell electrons. Now calcium has 2, so I've got 1 electron there and 1 electron there. Chlorine here is in group 7, so therefore it's going to have 7 electrons in its outer shell. So there's my Lewis dot structure. So knowing Lewis dot structure means the outer shell, valence electrons. Next, draw an electron transfer diagram to show how calcium chloride compounds forms. So therefore, I take my calcium, and it's got my 2 electrons. My chlorine has got 7. I haven't got a lot of room to do this, to be fair. Now, one of these electrons is going to go here. Then I've got an electron left over, so I need to draw another Lewis dot structure for chlorine, and I can show you that that's going to go there. So therefore my calcium, the 2 electrons have been donated, and now this chlorine will have a full outer shell and this chlorine will have a full outer shell, and life's good. That's going to leave us with calcium 2 positive, and we're going to have chlorine with 8 electrons and it's negative, and chlorine with 8 electrons and it's negative. And therefore I have my electron transfer diagram completed, where I have my before and with the electrons moving, and then I have my after, which is my charged particles here. Last part of this question, use the diagram above to write the chemical formula for calcium chloride. Well, it means I've got calcium, 1 of them, and chlorine, 2 of them, so it's CaCl2, and there's my answer. Next part of this question is looking like it's going to go into mole again because I can see grams. A particular cleaning product contains 25 grams of calcium chloride. Determine the amount in mole of calcium chloride in the product. Number of moles of calcium chloride equals mass over molar mass. So 25 grams is 25 divided by my molar mass of this. And my molar mass of calcium chloride, which is CaCl2, 35.5 for chlorine times 2, and calcium, using my periodic table, is 40.1. So therefore I've got 35.5 times 2 equals that, plus 40.1 gives me 111.1. And therefore 25 divided by my answer gives me the number of moles there is 0.225 mole. Next question is calculate the total number of ions present in the packet when the packet dissolves in water. Well, number of moles of ions equals how many ions do I have in here? I can clearly see I've got 3 ions in every calcium chloride. So therefore it's going to be 3 times the number of moles of calcium chloride. So therefore it's going to be 3 times 0.225. And I'll take that times by 3. Gives me 0.675 mole. Now it asks for the total number, so I then need to get capital N of ions, which means I take my number of moles times it by my Avogadro's number, 0.265 times by 6.02 times 10 to the power of 23. And then I do that, get my answer, times by 6.02 times 10 to the power of, where's my power of? 23. And I get 4.06 times 10 to the power of 23 ions. That's how many, whoopsies, that's how many ions there are in my thing. Lastly, determine the mass of calcium. So my mass of calcium equals number of moles times molar mass. My number of moles of calcium equals my number of moles of calcium chloride, because there's 1 calcium in every calcium chloride. So that's going to be equal to 0.225. So 0.225 times by 40.1. I need to go back over here. Now I want to get the exact number for this. So I'm going to go 25 divided by 111.1. That gives me my exact number of what that was. I'm going to times that by 40.1, and I'm going to get 9.02 grams. That's how much calcium there will be there. Again, this is how you can see a nice materials, an ionic compound question rolls into a particular mole question, and that's the answer there.